Good evening slash afternoon slash morning slash whenever you happen to be watching this calculus. Hope you're having a fantastic day. We have a little bit more on use substitution to do today. Now I'm going to start kind of getting you trained to the point where you can pick out your own use. So here's a couple of good choices for use to pick out what you should be using U for. Remember that for U, we're looking for some type of function, something to be inside. It can be either raised to a power, it can be something that appears in its denominator, or something that appears as an inside function of a composition. Right? Something of an inside function of a composition. If you remember, back on here, when we were talking about use substitution, right? The function that's the inside of this, that's what I'm trying to get to be U. Now, the fact that they call it g of x over here is really irrelevant. Just remember that what you're looking for is really something that either appears to be raised to a power, a denominator, or the inside of a composition. And number 3 is really going to be the one where we focus on the most, because number 1 and number 2 are pretty much the basis of compositions, right? F of g, that kind of stuff. So first, for example 1, look at this equation, or this formula here. The integral x squared plus 1 squared 2x dx. So what I'm looking for here is first to identify my u. Well, if you remember from number 1, it says u appears to be raised to a power. So I'm going to basically the inside of my chain rules here. That's going to be the overall kind of feeling to this. So I have a chain rule right here. Go to the inside, and x squared plus 1 is going to be my u. So then I can call du 2x. Ding, ding. All right. So from here, we've got, I'm going to rewrite this as the integral, and u is this, so this is all u, so it's u squared and 2x, oh excuse me, I didn't even finish this, it's over dx, right? So du is 2x dx, so this is du. So what I've got here then is u squared du. The integral of that is u cubed over 3 plus c, and then plug in u. X squared plus 1 cubed over 3 plus c. Okay? None too shabby. Example number 2. I've got 5 cosine of 5x. Well, I have a chain rule right here with cosine of 5x. I have an inside here. So I'm going to call the inside u 5x. Now I want to stop right here and just kind of say something. If for some reason this u did not work out, I can always go back and try a different u. U is just a tool that we'll use. So du is going to be 5 dx, right? Once you multiply everything across, it's 5 dx. So good. We've got u, and we've got du. I like to circle what they are. That way I know what I'm getting myself into here. So this is the integral of cosine u du, which is sine u plus c, sine of 5x plus c. All right. So again, I'm looking for anything that is inside of my function, right? I'm looking for the inside, something that's the peanut or the chocolate of the chain rule. So example number 3 here. The first thing I would do right off the bat is rewrite this as 2x minus 1 to the 1/2. That lets me see it pretty easily that 2x minus 1 is going to be u. So du is 2 dx. Right? Now, there's a problem with this. I've got u right here. I've got my power, so it's u to the 1/2, but I'm missing this 2, right? I'm missing the 2 du. So what I'm going to have to do here is divide out the 2, and I'm going to plug this guy into my equation now. So let me show you what this is going to end up as. This 1/2, this is 1/2 du. I'm just going to skip a step or two here. Remember that the 1/2, if we were to multiply that out, it's just a coefficient. So we can just bring it straight outside of the integral. Right? If I left it in here, let me write above this, I'll show you what it would look like. It'd be the integral of u to the 1/2 times 1/2 du. Well, all I'm doing is taking this 1/2 and moving it out here. And for the sake of time, I would like you to get used to doing that, just kind of automatically. So this is now u to the 1/2 du, which is 1/2. And the integral of u to the 1/2 is u to the 3/2 over 3/2, so that'll be 2 over 3 plus c, which your 2's will cancel. And plug in u, you've got 2x minus 1 to the 3/2 over 3 plus c. See, look at that. Look at how much easier that makes it, that u substitution. Imagine doing this without u substitution and how complicated this junk would get. All right. Example number 4. The integral of sine squared 3x cosine 3x. All right, well, the first thing I'm going to do is rewrite it as sine 3x squared. And that just kind of helps me see what's going on inside of the square here. Cosine 3x dx. So again, I'm going to go to the inside of my square here, and I'm going to call u sine of 3x. Now this is a chain rule. It's a chain rule within a chain rule here. So I'll have du is going to be derivative of the outside, which is cosine 3x, times the derivative of the inside, which is 3, dx. Now looking at this here, let me just simplify this real quick. Du is 3 cosine 3x dx. Now looking at the problem over here, I've got u right here. Cosine 3x dx is really close to this. The only thing missing is that 3. So let's divide out that 3. All right. So this is going to be du over 3. So this is going to be the integral of u squared du over 3. And remember, that's the 1/3 du, right? So let me go ahead and get us familiar with that. 1/3 out front. So this is going to be 1/3 u to the 3 over 3 plus c, which is, let's go ahead and plug in u sine cubed 3x over 9 plus c. 3 times 3 is 9. There we have it. All right, so same process. The only thing different today is we're just picking out what we want our denominator to be. Okay, number 5, again, I'm going to rewrite it and simplify it as much as possible first. So what I'm going to do is write this as x to the 5th, x to the 6th plus 1 to the negative 3 dx. And that allows me to see that u needs to be x to the 6th plus 1. So du is 6x to the 5th dx. And the only thing that's missing there, I have x to the 5th dx, fantastic. The only thing that's missing is the 6, so divide out the 6. Alright, so this is going to be u. This is going to be du over 6. So I've got the integral of u to the negative 3. Bring that 1/6 out front, du. Let's see what this will be. 1/6. This will be u to the negative 2 over negative 2 plus c. And then simplifying that before I plug it in, I'll have 1 over, let's go ahead and make it a negative 1, bring that negative up. 6 and 2 is 12, so 12 u squared plus c. Sorry, plus c, which is negative 1 over 12 times x to the 6 plus 1 squared plus c. See, so the process isn't that bad once you get used to it. Down here, again, first thing, number 6, I'm going to do is rewrite this as the integral of x, and this will be 2x minus 1 to the negative 1/2. Helps me see it better that way, so u is 2x minus 1. So du is 2 dx. Interesting. So I've got no 2 here. I've got u. I've got to compensate for this 2, so I'm going to divide by 2. So dx is going to be 1/2 du, or du over 2. The only thing that's missing is x, and I can't leave it like that. So what I'm going to do is solve for x. I'm going to take u equals 2x minus 1, and I'm going to solve for x. So u plus 1 is 2x, u plus 1 over 2 is x. So let me start by rewriting this as the integral of, plug this in here, oops, sorry, plug this in for x, u plus 1 over 2, u to the negative 1/2, and we can go ahead and bring the 1/2 out front, du. Now I can also bring this 1/2 out front since it's all multiplication here. This is going to be 1/4 the integral, and let's go ahead and multiply this all together here. If we bring this 2 out, we'll have u to the 1/2 times u, which is, or u to the negative 1/2 times u, which is u to the 1/2. 1 minus 1/2 is 1/2, plus u to the negative 1/2 du. Excuse me. And that's going to be 1/4. This will be u to the 3/2 over 3/2, so 2u to the 3/2 over 3. U to the 1/2 over 1/2, so 2u to the 1/2 over 1 plus c, which is going to be, if we simplify this out here, we've got the 2 and 4, so this will be 2 over 12, which is 1/6. So let's go ahead and plug in u here. 2x minus 1 to the 3/2 over 6 plus 2x minus 1, 1/2 plus c. Oh, I'm sorry, and over 2. Carnal sin. I forgot to distribute this all the way through. So 1/4 and 2 will be over 2. And then plus c is just c. Don't care what c is. All right. And that's about all she wrote.